Kia ora koutou. Here is a question for Nikhil and I think also for Oscar on partial fractions and integration. Guys, I'm going out of order with the requests that are coming in, partly because this one is a really quick and easy video to work through, and also one where I really think a lot of you could do with doing this question. So the first thing we've got to do is to find the quotient and remainder when we divide this by this. So you can either do that doing long division, or you can just do it using matching up, which is what I've done here. You're going to use the results of this question to do this one. And unfortunately, it's one where if you've mucked up this first part, the second part is going to be a little bit tricky. So let's have a look at the first part. So let's just write it out like this. 8x cubed plus 4x squared plus 2x plus 7 divided by 4x squared plus 1. So when I look at that, what I'm going to try and do is match up the 4x squared with something times 4x squared matching on this one. And we'll just go from there and see what happens. And it falls out reasonably nicely. So in here, we're going to get 2x times 4x squared plus 1. Now let's see what that's matched up. Well, that gives me, and we're going to put all of this over 4x squared plus 1 here. So now I've matched up the 8x cubed, and I've also matched up exactly the 2x there. So I'm left with 4x squared plus 7. So you can see that for this first term we've got 2x, and now I've got plus 4x squared plus 1 plus 6 divided by 4x squared plus 1. So all up, what do we have? Well, we've got 2x plus 1 plus 6 over 4x squared plus 1. So my quotient is 2x plus 1, and my remainder is 6, right? This top line here. If you're having trouble remembering whether the remainder is 6 or 6 divided by the thing, just do a simple numerical example, like let's do 4 into 57. Well, what do we get here? Well, we get 1, carry the 1, and 14 here, and so it's going to be 14 remainder 1. Okay, so that's why here we'd say the quotient is 2x plus 1, and the remainder is 6. So I'm going to do that now using long division as well. I'll try not to muck it up. So I've got 4x squared plus 0x plus 1 being divided into 8x cubed plus 4x squared plus 2x plus 7. So starting out in the same way, we're going to have 2x here, and we get 4x cubed plus 2x. You can see that this is just a different way to do what we just did. 8 is equal to 4 times 2, not 4. So we're going to subtract this now, and we're left with 4x squared plus 7 here. So here we get plus 1, 4x squared plus 0x plus 1. Subtracting that gives me 6. So exactly the same as what I did above. It's up to you which method you prefer. Okay, so that's the first part. Nikhil and Oscar, I think you probably can already see where the mysterious 3 is coming in. I think probably when you did this in class you didn't end up getting a 6. So for part 2, what we've got to do is to use that work that we've done to find the exact value of this integral. So I'll just give myself a bit of room. Okay, let's start again. So this integral, we'll call it I, is equal to the integral between 1/2 and 0 of 2x plus 1 plus 6 over 4x squared plus 1. And you should notice, basically, as soon as you see this here and this in here, that we're going to be working with a tan inverse. I'm going to do this in 2 parts. The first part is really, really easy, and the second part we just need to do backwards chain rule. So 2x integrates to x squared, 1 integrates to x. Let's evaluate that. And then we're going to have the integral of 6, or 6 times the integral of 1/2 to 0 of 1 over 4x squared plus 1 dx. So doing this bit first up, we get 1/2 squared, 1/4, plus 1/2, minus 0 plus 0. And in here, I can rewrite the 4x squared here as, I'm just going to erase this and do it as 2x squared. Okay, so I can either do a full substitution on this, but most of you shouldn't have to. What we're going to have is 6 times, so let's just try tan inverse of 2x. Right, now think about what happens when I differentiate this. I'm going to get 1 over 2x all squared plus 1, but because I've got a chain rule thing happening, I've got to multiply by 2 by the derivative of the inside function. But I don't have a 2 out here, so I need to divide that out just as we always do. Okay, so we're left with 3/4 here plus 3 times tan inverse of 2 times 1/2 minus tan inverse of 0. That gives me 3/4 plus 3 pi on 4, right? Because the angle whose tan is 1 is pi on 4. So there you go, that's that question done. A few nice little things in there. I think it's really common to see in the most recent couple of years of papers patterns like this coming up in some of the integration questions. It's testing that you really understand how differentiating tan inverse of x gets you 1 over x squared plus 1, and also testing that you have a good understanding of the chain rule. So thanks for watching. Keep on sending in the questions. I'm stopping for the night now, but I'll probably try and get through 4 or 5 videos for you guys tomorrow, starting with Archie stat stuff and then some vectors problems.